The sci-fi blockbuster in theaters, Project Hail Mary, has star-eating microorganisms in it. They start mowing down on the sun, dimming it, and potentially sending the Earth into an ice age. Sounds totally implausible, right? But it might not be as far-fetched as it sounds. I'm here to discuss what life could look like out there in the cosmos with computational biologist at Argonne National Laboratory, Nick Chia. Nick, welcome into the show.
Thank you so much. Glad to be here.
I gotta ask, I know the word computational and I know the word biologist, but I smack them together and I get a bit confused. Like, what does your day-to-day job look like?
Well, my day-to-day job is understanding life through simulation, right? So you think about all the things we know about life and all the things we don't know about life. And if I have to figure out how life works in a environment we've never seen before, I don't have a basis for that. I don't have a way to go out into space and sample, life because we haven't found alien life yet. So I have to simulate it. I have to figure out what the possibilities are, imagine them, and put them into a computer.
Do you look, I mean, maybe not you personally, but does your field look to sci-fi for creative ideas, or is it kind of the other way around? Sci-fi looks to the work you do to try to figure out what life could look like out there, how strange and different it might be.
I think it goes both ways, right? It's a really creative endeavor. I think a lot of us are inspired by sci-fi growing up, reading. For me, it was like Asimov and Arthur C. Clarke. And at the same time, I can tell you that many of the scenarios that are inside of the Project Hail Mary are real scenarios in astrobiology that have been thought about.
Okay, well, let's get to just those sci-fi versus biology. How close did this movie get? The organisms, they're called astrophage. They absorb sun energy. They store it efficiently. From your perspective, is this at all even scientifically plausible?
Okay, one caveat we have to just get out of the way here is these microorganisms have a magic mechanism for turning mass into energy and directing it, right? So we haven't figured that out yet. We haven't figured out how to turn mass into energy just at the snap of our fingers, but these microorganisms can. That aside, that one magic caveat aside, everything else is very realistic.
I'm trying to put that in lay terms. I'm thinking of like Einstein's equation, E equals mc squared, where energy equals mass times some huge number, speed of light squared. It's that equal sign, life doing the equal sign operation that we don't quite understand.
Right. Life just in this case can just magically do it. Imagine like, fusion is now, forget fusion. We don't even need fusion anymore. We can just immediately turn mass into energy. All energy problems in the world solved.
Now, it is a stretch, but some microbes actually live off of extreme energy sources, things like radiation, chemicals, deep sea thermal vents. So, yes, it's a huge leap to go from a thermal vent to a star, but
Mhm.
theoretically, maybe possible.
So survival definitely, I mean, okay, so yes, absolutely. So there's a lot of extremophiles, right? There's I'm going to throw some names out, right? But there are organisms, well, I'll try not to, but there are organisms that live and breed at 130 degrees Celsius, deep under the sea, so super high pressure, super high temperature. There are organisms that eat radioactive waste. Fun fact, you think about radiation damaging the DNA. One trick those microbes have is that they shatter their DNA into thousands of pieces and reconstruct it at will.
I can do that. I just don't want to. But feeding directly on stellar radiation, I mean, how could that even work? I guess the answer is we don't know.
Right, right. I mean, like there's some chemical and physical limits, right? Why don't they just boil off or why don't they just burn? But if you can accept that they can turn mass into energy and energy into mass, then you think, if the sun has a lot of heat and light energy, they're converting it into mass, is a way to think about that.
Interesting. And then, of course, there's the energy storage. I hope I'm not giving away too much, but like in the movie, the way they power these interstellar spacecraft is using the microorganism itself as a sort of engine, being like, hey, we
Yeah.
discovered this thing that can store energy from the sun. If we use it in an engine, we can burst out huge amounts of energy and go from star to star.
It's brilliant. Yeah. I mean, if you have that vehicle for just at will deciding, I want energy now, I want mass now, and directing it, right? They also show they know how to direct it. It's not just energy, it's that they can direct that energy where they want. Then you can solve so many problems, right? Just like they use in the movie.
Now, are we often too Earth centric? Which is to say, are we often, when we imagine aliens, even in science fiction, we kind of picture them as humans, and this is a much better portrayal, like an exotic microorganism that looks nothing like what we've seen on Earth. It eats stars, it colonizes solar systems. Is this the kind of big, wild thinking we need to do when we try to pretend or imagine what could be out there in the cosmos? Or is it going to be green men that are basically humans with bigger heads?
No, it's actually one of the things that I think in the field we work very hard at is to try to make sure we imagine realistic scenarios and we're not just sort of scenario adjacent to ourselves, right? Um, and that's one of the wonderful things. I don't want to give away the movie, geez, but there's another alien species, very cool. The details they leave about in the book come from, as far as I can tell, theories about other types of chemistry that could drive the energetics of life. So,
Well, they show the rock alien in the trailer for the movie
okay, so
Rocky,
I can
so
say
I
that,
feel like we're
yes.
not giving away too much. It's like a half humanoid, half rock creature.
Right. So he's from a world that thrives on a reducing chemistry. So we're an oxygen chemistry, right? Which is it's the difference between donating our electrons to gain energy and accepting electrons to gain energy. And Rocky's from a completely opposite chemical spectrum. His energetics work in an opposite way, and we know this. And I won't say why we know this. It's fine. Too many, too
Too
many.
many spoilers.
Yeah, yeah.
But even that seems a little bit far fetched to me because although they're rocks, they seem just so human. They have language that. I actually think like bacteria or small microorganisms, that's probably what we're going to find. I have no basis with which to make this claim, though.
Well, those that makes sense, right? Because intelligent life is a subset of life, right? And it makes a lot of sense. There's a lot of life out there. There's no other life form on Earth that has built a spaceship, right? So you're going to necessarily find life more abundantly than intelligent life. And so you're absolutely right. And on Earth, I will mention one of the things that people forget is that it is a microbial world. There are trillions of microbial species, right? Depending on how you break species up. And there are very few relatively large creatures like us.
So if we find life, it's probably going to be pretty small. Would we even recognize it if we found it? I mean, these are the deep questions right now.
It's hard to say, right? I mean, if it looked like us, we would recognize it. All the probes that go out to other planets do have sensors to try to sense the building blocks of life, and they try to cover as many building blocks as possible. Actually worked. We used to have in my lab a scientist that worked on some of the sensors for the Mars probe for life chemistry. So yeah, we look at all possibilities.
Project Hail Mary, we've kind of gotten off the mark, but I love that we have. Did you enjoy it? Did you think it was a fun movie? Would you recommend it to people?
I love it. I love it. I've seen it 3 times now.
Oh my goodness, that's so many more than one, which is all I've seen it. I liked it. I liked it. I had some issues with it, but I liked it. But those issues, perhaps for another time. I think I made them clear last night on the program. Well, Nick Chia is a computational biologist at the Argonne National Laboratory. Nick, it has been a joy having you on the show. Thank you so much for being here.
Thank you for having me. It's been a joy here as well.